Hello, everyone, and welcome to this introduction webinar of Lakeview. My name is Bas. I'm the product manager at Lumix, and before I hand the word over to my colleague Afke, we will dive into the technical part of Lakeview. I want to just share 2 slides with you guys on how we see Lakeview and what our bigger vision is of where we're heading. And to really put it in one phrase, Lakeview is a data analysis software that enables any scientist to instantaneously analyze their C-trap data. And I really intentionally put 2 parts here in blue, the any scientist here, because we really want to make this such that everyone with different backgrounds can really start doing this kind of data analysis. And the second part on that instantaneously analyze, because we really think that by doing this, you can massively increase your throughput and really can check your data right away. And where it fits in the bigger scheme and the bigger vision we have as Lumix is that this science used to be very much something for specialists. And we really want to move towards providing a full end-to-end solution. And although at the moment we are having an instrument that does very well in the execution part, we also even have some stuff on the sample preparation, as you know, with the Lumix store, and also on data analysis already with PyLake. We really want to make this a whole one solution from start to finish. And that's what we are going to work towards on the long term. But for today, we really want to focus on Lakeview, as we think it is really an enormous step in bridging the barrier of making this thing accessible to every scientist. And one good thing to notice also is that although Afke will talk to you a lot about what Lakeview is today, as you can see here on the left, it's something that will be improved and changed all along the way. And you can see here a list of features that are coming, and we really strive to have multiple releases throughout the year. So whatever is not there, don't worry, more is yet to come. But the order and really what we put in there also really depends on your feedback. So this is immediately an open invitation to all of you to provide any feedback and share with us anything you may need or may want. That's all I wanted to say as an introduction, and really now I want it over to Afke, who's going to dive into the technical part of it.
Okay, Bas, thank you for the introduction. Yeah, so my name is Afke. I'm the customer success data scientist in Lumix, and I've already been using Lakeview a lot for analysis myself, and I've also given several workshops. And in my experience, any user can just start analyzing data right away, and it really speeds up the analysis. So I hope, you'll find a way to integrate it in your workflow too. And let me now switch to Lakeview. All right, so here you can see Lakeview, and I already loaded 2 data files, and I will walk you through a typical data analysis workflow. And along the way, I demonstrate all the new features that we have in Lakeview. And if you have any questions during this demonstration, you can ask them in the chat, because my colleague Ray over here, he is from the software team, and he can directly address your questions in the chat. And at the very end, we will also have some time for questions. So let's get started. So here you see Lakeview, and I already loaded 2 data files by dragging them into the window over here. The data files are listed over here. And as you can see, when I hover over them, you can see which items are associated with each file. And this file, for example, has 3 items. It's a kymograph, channel data, like the force and the distance, and a scan. And already by just clicking on one of the items, you can get some useful information. You can get, for example, the duration of the kymograph, information on the force response, and you could go to this icon over here to open a Jupyter notebook. But of course, that's not what we're going to do today. We're going to use the new way. We're going to use Lakeview to analyze our data. So let's go ahead and open this kymograph. Here you see the results. And the first thing I'm going to do is to change the contrast of my kymograph because it's a little bit dark. So I will go to the menu over here and improve the reds and the green. So what you see here is kymograph. The red bands are the beats that cause some fluorescence. The red traces here, they are the markers. And in green, you can see Cas9 binding and unbinding. And since this particular experiments also had changes in the force, I actually want to correlate my kymograph with the force channel with force 2x. All right. So now we're all set up for the analysis. And a very typical kind of analysis is to track your binding events and then compute quantities like the diffusion constant and unbinding. So that's what we're going to do. Go into this icon to switch to the kymograph analysis. And the first step in the analysis is to select the region of interest that we want to analyze. And I am interested in a region with constant force. So I'm going to put the boundary all the way here. And I want to crop the beats like so. That looks good. Confirm. And I'm going to now remove the force because I don't need it anymore. So here in this next window, we can already see the results of the tracking using the default tracking parameters. And you can also adjust the tracking parameters using the panel over here. So for example, using these toggles here, you can choose which channels you want to track. And since we don't have any signal in blue, I'm going to switch it off. And I want to start looking at green, not red. So I'm going to select the green channel over here. Now, using these tracking parameters here, you can tune the tracking algorithm. And what each parameter does and how it works is very, very well explained under the tooltips. So I'm not going to highlight all of them, but I will just explain the ones that we need today for optimizing the tracking. And the first one is the minimum intensity. And this is basically the photon count from which you would call something a tracking event. So if I would set it very high, I would not track anything. And if I would set it very low, I would start tracking a lot of noise. So I'm going to put it somewhere over here. Now, the next parameter is the positional search range. And basically, this is telling the algorithm how much your protein is diffusing. So if I would set it very high, you would get, let me zoom in a bit. You would get tracks like this one that make very large positional jumps because the algorithm is assuming a lot of diffusion. Now, our protein is not diffusing, so I'm going to put it to a very low value. Now, the last parameter I want to look at is the expected spot size. Because when I look at this trace, for example, I notice that the algorithm, it looks like one binding event, but the algorithm thinks it's like several binding events very close together. And this suggests that the spot size was actually set too small. So I'm going to put it to a higher value. And it already looks a lot better. Now, the Kymo tracking algorithm in Lakeview is pretty good, but it's never perfect. So that's why we also allow for some manual adjustments. And the first type of manual adjustment is to remove a track. So for example, if I select this one, then I can throw it in the trash bin. And you can always make up your mind and undo the deletion. Now, the second type of manual adjustment is called stitching. So let me, for example, zoom in on this one. Here it looks like we have one binding event, but the algorithm thinks it's 3 different binding events. So in such a case, you may want to activate stitch tracks over here. And then you can start stitching. You can stitch from the beginning, from the end to the beginning of a track, but you can also stitch like away from the ends, like so. And then the loose ends are automatically deleted. And you can always make up your mind and undo the action, of course. So yeah, these are the 2 types of manual adjustments. And maybe you noticed that once I started doing this, this warning appeared over here. And this warning is basically telling you that whenever you're now going to change any of the tracking parameters, all of the manual adjustments will be deleted. So the best workflow is to first optimize the tracking parameters and then do the manual adjustments. One last comment about the tracking. So a question I always got in workshops is, how can I see my raw kymograph data underneath the tracks? Because I want to compare the 2. And the way I like to do that is always to just zoom in a lot, like I did now, and you can very clearly see the data as well as the tracks. And notice that you can zoom in one axis by hovering over this axis, like you can zoom in on the positional axis. And you can also zoom in on the time axis, like so. Or you can just zoom in on both axes at the same time. All right. So that's for the tracking. This looks pretty good. Let's go ahead and finish the analysis. So now we see the full kymograph again, and together with the results. And I see something, you might often have that in analysis. I forgot to track the red ones, but luckily you can go back to your original analysis and you can always still edit it. So you can click edit, switch to the reds. You can optimize it and then finish it again. All right. So these are the tracks that we got. Whenever you finished analyzing, you also get this indicator, these rainbow colors to show that you finished the analysis. And you can also always choose to not display the tracks if you want to. Or you could decide to not display one of the colors. So once you finish tracking, Lakeview automatically does 3 types of analysis. And these 3 are listed here on the top. I will go over them. First of all, there's the binding position. And what this graph does is the following. It takes a time window in the region of interest, and then it looks at all the positions of the tracks and makes a histogram. So yeah, it is like a histogram of the positions of the tracks. And note that we don't take any intensities from the kymograph. It's just purely looking at the positions of the tracks. So for example, in red here, we can clearly see the positions of the 2 markers in this graph over time. And you can change the time windows over which are averaged by changing the number of bins. For example, if I would change this to 1 bin, we would basically average over the entire region of interest that we selected. Here you see the same graph, but for green. And on this graph, you see why this can be very useful visualization of your data. It's a very good way of looking for a specific binding, for example. Like this event here in the middle, it might be a specific binding event. And in addition to this graph, you also get the binding, what we call binding frequency, is binding events per second. And you get more information on how this graph was made. Okay, that's it for the binding position. So let's switch to the binding time. So for the red signal, we did not have enough statistics. So that's why Lakeview is not showing anything. But luckily for the green, we do have enough data. Here you see a histogram with the duration of each tracked event. In addition, Lakeview fits an exponential distribution to get the binding lifetime. And for this fitting, we actually use maximum likelihood fitting. And this method works directly on the data. And that's a really great approach because this method does not depend on the number of bins that you choose for your histogram. Yeah, because it directly uses the underlying data to fit on. And in addition, you get the dissociation rate constant, which is the inverse of the binding lifetime. And for more information on the methods used, you can always go to this tooltip. And there you also find a link to the PyLake documentation, which is very extensive discussions on how this graph is made. Okay, that was it for the binding time. Let's go to diffusion. I'm going to switch to the green. Yeah, so Lakeview also computes the diffusion coefficient for every individually tracked event and puts it in a histogram here. And you also get an average diffusion coefficient where every track is weighted by its length. And this average is also presented over here. Now, for some of you who may be familiar with diffusion analysis, you may be very familiar with mean square displacements, or MSD. And very often the approach for getting the diffusion coefficient is to first compute mean square displacement and then get the diffusion coefficient. So for Lakeview, we decided to use instead another method, which is called covariance-based estimator. And this method, it works directly on the data. So there's no mean square displacement that you compute. It works directly on the data. And it's a very fast and unbiased approach. That's why we selected it as a method for diffusion analysis. And if you want to read more about this method, you can again go to the tooltip and to the PyLake documentation, where we present this method and also the original citation. So this was a full overview of all the kinds of analysis that Lakeview can do right now. But very often, you don't analyze just one kymograph, but you analyze multiple. And you want to, with similar conditions, you of course gonna need similar parameters for tracking. So to speed up this whole analysis, we have given the option to copy tracking parameters. And now I can open another kymograph. I can quickly start analyzing, select the region of interest, confirm, switch off the blue, and I can then paste the tracking parameters. And then they're directly optimized for the conditions of this kymograph. And then, I click finish and I directly have all the results of the analysis of this other kymograph. So we just analyzed 2 kymographs. If you want to export the results of your analysis, you can go to this icon over here, where you can export the kymograph, the channel data, and the results of the analysis, like the track coordinates, binding position, diffusion, binding times, etc. So we just, you get a full workflow and we just analyzed 2 kymographs. And now it's your turn to analyze data. If you want to have more technical introduction and answers to frequently asked questions or give feedback, you can go to the web page that I displayed over here on the left. And if instead, you're interested in getting Lakeview, you can go to the website displayed here on the right. Yeah, so this was the full workflow. And yeah, I wish you a lot of fun analyzing data.